Once you understand why scientific notation is used, the next thing you need to really look at is, can you do the problems? So we're going to look at a few practice problems. We're going to do a couple of different types. Let's say that you're given, this number. And you're asked to put it in scientific notation. So what do you do first? Well, you begin with figuring out where the decimal naturally is. And in this instance, it's at the end of the zeros. In order to put it in scientific notation form, we know that you have to move the decimal way down here, in between the 6 and the 2. So when we go to write our new format, it's going to be 6.2963, which seems like a lot, but since none of those are zeros, you have to keep them with it. And then you're going to put your 10, and the question is it a positive or a negative exponent? Well, remember, if it's a positive exponent, you're dealing with a big number. So in this case, it's definitely a big number. So then I count the number of spaces from my original decimal spot to my new decimal spot. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's where I'm going to put it. So your new answer is going to be 6.2963 times 10 to the 9th. If we're looking at another example, we'll try a new color here. We've got a pretty small number, and you've been asked to put it in scientific notation. Same thing applies. First of all, you figure out where your decimal sits in that number, and it originally is going to be over on the left, and you're going to need to give it a new spot of right between the 1 and the 3. So that allows you to have your 1.32 times 10 to the something format. Since this is a small number, your exponent is going to be negative. And if it's a negative exponent, you're dealing with a small number. So again, you've got to count the spaces between the original decimal point and the new one. So it would be 1, 2, 3, 4, 5, 6, 7, 8. So now it would be 1.32 times 10 to the negative 8 power. So either being given a large number or a very small number, you can change it into scientific notation. But what if you're given scientific notation and you're asked to have just a regular number? So let's say that you're given 4.51 times 10 to the 5th. First question, is it a large or a small number? Well, it's got a positive exponent, so you know that you're dealing with a larger number, which helps me because I tend to get confused on things. And it's also going to tell you that you're moving the decimal 5 places to the right. And that's what this is saying. So when you're doing that, you would have your 5, 4, 1. And you'd know that you'd go 1 and 2 spaces, and then to get to your 5th, you would add 3 extra zeros. And that would tell you that 5.41 times 10 to the 5th is actually 541,000. And that would be the actual number. Going in the opposite direction, though, well, let's say that you're dealing with, let's just use that same number. 5.41 times 10 to the negative 5th. Because of that negative there, that means you're dealing with a small number. So, you're still going to take that 541. I'm going to start it over. I'm going to start it over on the left. I'm going to start it over on the left there, and I'm going to put 541. And I know that my decimal is naturally between that 5 and the 4, and I need to move it 5 places. So I'm going to move it past my 5, which means that I'm also going to need to add 4 zeros to the left. So, in essence, 5.41 times 10 to the negative fifth is actually 0.0000541. I'm going to do one last question. What if you were given this problem, 5.41, I tend to like that one, times 10 to the 0? That looks a little bit scary. My first question would be, I don't know, it must be wrong. It's not wrong. 10 to the 0 is going to be 1. So if you imagine that just being a 1, well, 5.41 times 1 is still 5.41. So don't let the 10 to the 0 power confuse you. It just means that it's going to be 1. Hopefully this was helpful.